Hello, STT 315. This is recitation 11. So let's start off with question 1. Point estimate of mean. Following is a random sample from a certain year person incomes of industry workers in the state of New York in thousands of dollars. So here are 10 different incomes of industry workers that we have here. So the first question is, what is the point estimate of the mean? So we're just going to add up all of these numbers and then divide that by n to find x bar. So when you add all of these up, 16 plus 17.1 plus 14.8 plus 19.4 plus 13.2 plus 17.6 plus 18.1 plus 13.2 plus 13.2 plus 16. And then divide that by 10, which is the total number in the sample. We get 158.6 divided by 10, which is 15.86. So that is the point estimate of the mean. What is the point estimate of the standard deviation? So here, S is going to equal the square root of the sum of our xi minus x bar squared divided by n minus 1. So, which can also be rewritten if you want to expand what x bar is, like we did above. You can write it in this way as well, because x bar is xi squared divided by n, or xi divided by n, but here we're dealing with the squared, so it can be expanded this way as well. So when you put in our numbers, so first we'll do 16 minus 15.86, which is the mean squared, plus 17.1, which is the next number in our sample, minus the mean, which is 15.86 squared, plus, then you would do the next number in the sample, so that would be 14.8 minus the mean of 15.86 squared, and then you're going to do that for every single number, and then the last number is 16 minus 15.86 squared, divide that by 9, and then you'll take the square root of the whole thing, and you'll get 2.2237. Point estimate of proportion. A market research worker interviewed a random sample of 12 people about their use of a certain product. The results in terms of Y or N for yes or no. So yes, they are a user of the product, or no, not a user of the product, are as follows. So here we have our 12 different people. And so each person is either a yes or a no. So if we want to estimate the population proportion of users of the product, so yes means they are a user of the product. So we're going to see, okay, how many total yeses do we have? So we're going to count up our Ys. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 Ys. And then we're going to divide that by the total number in our sample, which is 12. If you add up all of these, that's 12. And it also says that we have a random sample of 12. So 9 divided by 12 is 0.75, and that is our p hat. Oops. Sorry. Let's skip too many pages. Okay, so now we're on problem 3. Let me zoom in. All right, so here we're going to be doing normal CDF. So on a given day, the average price per share on the Big Board Composite Index in New York rose 20 cents. Assume the population standard deviation that day was 9 cents. If a random sample of 36 stocks is selected that day, what is the probability that the average price in this sample was a rise between 18 and 22 cents. So we want to find the probability that X bar lies within 18 and 22. So if we want to visualize that, here we have our mean of 20. So 18 is on the left, 22 is on the right of that, and we want to know the area under the curve from 18 to 22, so the shaded region. So we're going to use the normal CDF function in our calculator, and our lower bound is going to be 18, our upper bound is 20, and then our mean is 20, or sorry, our upper bound is 22, and then our mean is 20, which is right here. It's the average price per share that rose 20 cents, and then we want to find the standard deviation, so that would be 9, but we have a total sample of 36 stocks, so we're going to do 9 divided by the square root of 36, and we're doing that because we're interested in the average price. What is the probability that the average price in the sample was a rise between these? So like with for the average, we're dealing with X bar, so that's why we have to do the 9 divided by the square root of 36. So don't just put 9 there. And then, so when you do that in your calculator, you should get 0.8176. Number 4, Mercury makes a 2.4 liter V6 engine used in speedboats. The company engineers believe that the engine delivers an average power of 2,000 horsepower and that the standard deviation of the power delivered is 80. A potential buyer intends to sample 49 engines, each engine to be run a single time. What is the probability that the sample mean will be less than 2010 horsepower? So here we're dealing with the sample mean again, and that it will be less than 2010 horsepower. So here, that's why for the standard deviation, we're dividing by the square root of our sample number, which is 49, highlighted in green there. So that's why we are going to have 80, which is the standard deviation of power delivered here, divided by our total sample, 49. And then our mean is 2,000. That's the average power of horsepower. So that's 2,000. And if we want to determine what is our lower bound and upper bound, so what we're interested in is what is the probability that the sample mean will be less than 2010 horsepower. So we have the probability that X bar is less than or equal to 2010. So we have, if we want to look at our graph here, we have 2000 is the mean, so that's in the middle of the bell curve, and then 2010 is somewhere to the right of it. And so we're interested in the probability that X bar is less than or equal to 2010, so that we're interested in the shaded region here. So our lower bound is going to be negative infinity. So in our calculator, we can write negative 10 to the 10. And then our upper bound is 2010. So we're going to put that here. So when you put this into your calculator using the normal CDF function, you'll get 0.8092 as your solution. Question 5. When sampling is done for the proportion of defective items in a large shipment where the population proportion is 0.08 and the sample size is 100, what is the probability that the sample proportion will be less than 0.09? So we want to know the probability that p hat is, or sorry, not less than, will be at least 0.09. So it can be 0.09 or greater. So we want the probability that p hat is greater than or equal to 0.09. And so we're going to use normal CDF, and our lower bound is going to be 0.09 and our upper bound is going to be infinity. So we'll put in our calculator 10 to the 10, and then we're going to have P here, and then our square root of P times 1 minus P divided by N. So in this problem, our P is 0.8, which is given right here, the population proportion. And then here we would have, oh, sorry, it should be 0.08, not 0.8. So this third input value here for normal CDF should be 0.08. And then for our fourth input of that, we would have 0.08 times 0.92. So that's 1 minus 0.08 is 0.92 divided by the sample size, which is 100. So when you put that in your calculator, you should get 0.3562. Okay, so that is the probability that the sample proportion will be at least 0.09. Now we're on problem 6. Okay, so let's zoom in there. Problem 6. An insurance company handling malpractice cases is interested in estimating the average amount of claims against physicians of a certain specialty. The company obtains a random sample of 100 claims and finds the sample mean 16,000 and sample standard deviation S equal to 4,000. Give a 90% confidence interval for the average amount of a claim. So for our confidence interval, we are going to do X bar plus and minus M. So first, okay, what is our M? Our M equals K times S, our sample standard deviation, divided by the square root of N. So first we have to find, okay, what is K, so we can input that here. So K equals the inverse norm function of 1 plus our level of confidence that we're interested. So here we have the 90% confidence interval, so we would have 1 plus 0.9 divided by 2, and that equals 1.645. You can also remember the table that I showed you in a previous recitation video that for a 90% confidence interval, but it's good to know this way because you may have something, to have to calculate a confidence interval with, like, let's say a 98% confidence interval or something. But anyways, so this problem is a 90% confidence interval. So let's go back to solving our M now that we know what our K is. So M equals K times, so our K is 1.645 times S, which was given here, 4,000, divided by the square root of our sample size. And here our sample is 100 claims. So we're going to divide that by the square root of 100. So when you solve that, you get 658. So our confidence interval is X bar plus or minus M. So that would be our X bar is 16,000, which is here, the sample mean, plus or minus 658. So our lower bound of our confidence interval, of our 90% confidence interval, is 15,385, and our upper bound is 16,658. In a survey, so number 7, in a survey conducted by a firm, a sample of 120 residents in two-story homes, 36 were found to own their houses. Find a 85% confidence interval for the proportion of residents of two-story houses who own their own house. So now we're dealing with the 85% confidence interval. So let's first find what our K is. So I'm going to zoom out a little bit. Our K is the same, there's the same way to compute it, however, as we did before, but our confidence level now is, we want an 85% confidence interval. So instead of 0.9, we're going to have 0.85. So the inverse norm of 1 plus 0.85 divided by 2 equals 1.4395. So that's our K. So now we can solve our M. So we would input our K, which is 1.4395, and then we would have times the square root of P times 1 minus P divided by N. So our P here is 36 divided by 120, because we have 36 homes were found to, so we have, 36 homes for out of a total of 120, because our total number of residents in our sample is 120. And of those, 36 were found to own their own houses. So we would do 36 divided by 120, which equals 0.3. So if we go back to solving what our M is, here our P is 0.3 and our 1 minus P would be 0.7. And then we divide that by the sample size N, which is 120. And then we take the square root and multiply by that by K, and we get 0.06. So M equals 0.06. And now we can finally solve the confidence interval because we have our P and our M. So our confidence interval equals P hat plus or minus M. So that equals 0.3 plus or minus 0.06. So our lower bound of our 85% confidence interval is 0.24, and our upper bound is 0.36. So a continuation, number 8 is a continuation of number 7. So the firm came up with a confidence interval of 0.22 to 0.38 for the proportions of residents of two-story houses who own their house. What confidence level did the firm use in percent? So here there's a few steps. So here our M equals 0.38, which is the upper bound of that interval, minus 0.22, which is the lower bound of the interval, divided by 2. And that equals, when you solve that in your calculator, 0.08. And we also know that our M equals this expression here. It equals K times the square root of P times 1 minus P divided by N. So here we know that this expression equals 0.08, which is our M. And then we have still, our sample is, our sample should be 120, not 100. So let me just see. I'm going to pause this video and then resume because I may have made a mistake. So let me just pause recording. Okay, the recording is resumed. I'm back. So I fixed my mistake in the few seconds ago. I had N equal to 100, but the sample size is 120. So I made my changes in gray in case if you looked ahead in the video. So picking up where we left off. So we solved what M is, and we have 0.08 equal to this expression. So, and then we have our N equal to 120. So now we're on the second line of 8. So here, to find what P is, we're going to find the midpoint of this interval. So we have P equal to 0.38 plus 0.22 divided by 2, which equals 0.3. So that's our P. And the reason why it's the midpoint, because if you think about it, here we have our, P hat plus or minus M. So our P hat is going to lie in the middle of this interval. It's going to be the midpoint. So 0.3 is the middle of this interval. So that's kind of the same idea here. Our P equals the midpoint of the interval that the firm came up with. So, which is 0.3. And then we want to solve for what K is. So here we have an expression where K is unknown. So to solve for K, we're going to divide by the reciprocal of this fraction. So that would mean that we would have k equal to 0.08 times the square root of n, which is the denominator, divided by the square root of p times 1 minus p, which was the numerator. So I'm just solving algebraically for k here. And so if we plug in what we know, we get k equal to 0.08 times 120, which is our sample size, or the square root of 120, divided by the square root of p, which is 0.3, times 0.7, which is 1 minus 0.3. And that gives us 1.91237. So the confidence level alpha is going to equal our normal CDF function with negative 1.2137 or negative 1.9124. And then our upper bound is 1.9124. And then in my calculator, I did the mean of 0, standard deviation 1, and that gave me 0.944, which is 94%. And now here's a continuation still, which is problem 9. So the firm requires a 95% confidence interval with width 0.15 for the proportions of residents of two-story houses who own their own house. What is the required sample size? And then assume nothing is known about the population proportion of residents who own two-story houses. So here we have our equation for solving for n, which equals k squared times p times 1 minus p divided by m squared. So our k equals 1.96 squared, and our p is 0.5, so our 1 minus p is 0.5, and the reason we do this is because what's highlighted here in purple, assume nothing is known about the population proportion of residents who own two-story houses. So whenever a problem says something along those lines where we don't know, assuming that we don't know about the population proportion, we're going to use the p of 0.5. And then we're going to divide that by m squared. So our m is 0.15 divided by 2. So we're going to square that. And then when you enter this into your calculator, you should get that the n is greater than or equal to 171. So that is the required sample size of at least 171. And this concludes recitation 11. I hope this was helpful. Bye-bye.